Yesterday I was at Oxford University and I drove from Oxford to Cambridge with constant velocity.
With 40 mile per hour. Oxford to Cambridge. Alright, Oxford. As soon as I arrive at Cambridge, I return to Oxford again for some reason. I return to Oxford again. Alright, I return to Oxford again. So the distance remains same, but I change my constant velocity, 60 mile per hour. So it's going to take less time, of course, because the distance remains same. Distance remain d. Distance I'm not going to tell you right now. I'll tell you in the future. The distance remains same, but I move faster. So it's going to take way less time. All right. So what do we need to find? We need to find a list of things. Number one, we're going to find average speed. Number two, you're going to find average velocity. Number three, you're going to find the distance. Number four, you're going to find the displacement. Number five, we're going to find the dt graph. Number six, we're going to find st graph. Number seven, we're going to find displacement versus time graph. Number eight, we're going to find vt graph. And number 9, we're going to find AT graph. Let's see how that goes. Okay, let's start with the speed, average speed. Average speed is equal to total distance over total time. All right, distance is not given. Distance is not given. So what we can say d. All right, from Oxford to Cambridge is d. From Cambridge to Oxford is of course d, because the distance remains same. All right, so we can say that that d from Oxford to Cambridge is d, plus from Cambridge to Oxford is also d. So d over the time. So the total time. So we can call this one from Oxford to Cambridge t1. T1, because remember, time is not going to be the same, because that's why we're going to have to use T1 and T2. Time not going to be same is because your trip number one, you move from Oxford to Cambridge, you move 40 mile per hour. That's going to take much more time than T2, because T2 you move faster. All right, so T1 would be d over velocity, and T2 would be d over velocity. By the way, velocity 1 and velocity 2. Okay, velocity 1 and velocity 2. Okay, so the T1 would be d over velocity 1 would be 40, and T2 velocity 2, this is velocity 2, velocity 2 would be 60. Now you come over here, you plug it in, you're going to write T1 plus T2. So then average velocity, average speed is 2d over T1 is d over 40 plus d over 60. So average velocity is 2d over 120, 3d plus 2d. So that's going to give you 2d over 1 times 125d. So this is 1. So dd cancel 5 goes to 120 24 times. So 48. Average velocity is 48 mile per hour. So we found the average speed, which is 48 mile per hour. Now you're going to find the average velocity. Now notice that average velocity is 0. Average velocity is 0 is because the formula for average velocity is d final minus d initial over delta t. All right, displacement final minus displacement initial. Displacement final is Oxford. Displacement final is Oxford, but displacement initial is also Oxford. All right, displacement initial is equal to displacement final because you return to Oxford. So then 0 over delta t, which is 0. So average velocity is 0. Now you're going to find the distance between Oxford to Cambridge. The distance between Oxford to Cambridge, if you take a ruler and find the distance between Oxford to Cambridge, say I did it turned out to be 120 mile. So the distance is 120 mile. It is actually 120 mile. It is actually 120 mile. Okay. All right. Now, what would be the displacement of the strip? The displacement of the strip would be 0, because displacement, remember, final is 0 and the initial is 0. So displacement is 0. Now we're going to do the dt graph. Remember, dt graph always positive, so you don't need another region in a coordinate plane. So now let's find the time. So time 1 is, you remember d over 40 because this is 40, and time 2 is d over 60. So d is 120 over 40. So the time 1 is 3 hour, and time 2 is d is 120 over 60. So time 2 is 2 hour, and time 1 is 3 hour. It took 3 hours from Oxford to Cambridge, which makes sense, and it took only 2 hours from Cambridge to Oxford, which also makes sense. So total trip is 5 hours. So 1, 2, 3, 4, and 5 hours. And the total distance is so from Oxford to Cambridge is 120. So then round trip is of course 240. So let's go by 100, 150, 200, and 250. So we need 2 points. So the initial time and initial distance, they both are 0. Okay, and the final time is 3 comma what? 3 comma 120. So 3 comma 120. This is from Oxford to Cambridge. And what is the slope of this one? The slope of this one is 40. How did I get 40? If you do 0 comma 0 and 3 comma 120, the slope will be 40. y2 minus y1 x2 minus x1, and that's give you 40, and that matches with this one. Okay, now from Cambridge to Oxford, what is our first point? First point is 3 comma 120. What is the second point? Second point is 5 comma 240. 5 comma 240. So see, this line is steeper, 5 comma 240. So you see that this line is steeper than the green line, is because the magnitude of the blue is more than the magnitude of the green. What am I talking about? So let's find the slope, and then you'll see that. So this point is 3 comma 120, and this point is 5 comma 240. So x1 y1 x2 y2. So y2 minus y1 x2 minus x1. So y2 is 240 minus 120, and then 5 minus 3. So then 120 over 2, so 60. So this slope is 60, and that makes sense because that's what the constant speed was. So the dt graph, the slope is the velocity. The slope of dt graph is velocity. So from Oxford to Cambridge the velocity is 40, and from Cambridge to back to Oxford the velocity is 60, which makes sense. All right, now we're going to do what are you going to do? We're going to do the speed versus time graph from right here. 1 2 3 4 5. This is 3 and this is 5. 3 is important because at 3 you turn back and return to the Oxford. All right, so I'm going to take the slope of the green. All right, okay. So when it is diagonal line, it become a horizontal line. So this is 40. All right, now I'm going to take the slope of this one. The slope of this one. Okay, so this one is 60. All right, this one is 60. All right, so from Oxford to Cambridge the speed is 40 mile per hour, and from Cambridge to Oxford again the speed is 60 mile per hour. Okay, all right, hopefully that makes sense. The first point is 0 comma 0. The first point is 0 comma 0. What is the second point? The second point is 3 comma what? 3 comma 120. Yeah, 3 comma 120. So let's go by, this is 120. 3 comma 120. All right, so this is from Oxford to Cambridge. Now from Cambridge to Oxford, at the end of 3 hours you are at Cambridge. You want to return back to the Oxford. So at 5 you are back to Oxford. So this slope is more steeper than the red one. This slope is negative 60 and this slope is positive 40. Okay. All right, in fact I didn't need to use that. Sometimes math guide you, sometimes physics guide you. All right, now since I have this space, I'm going to use this space for velocity versus time. Why not? So for the velocity versus time graph, probably I need to use it. I still don't know. We'll see. We'll figure that out. So this is velocity. So 1, 2, 3, 4, 5. So this is 5. This is 3. Okay, now this is 40 and this is negative, this is 40 and this is negative 60. Okay, yeah, see, I need to use this 40. Okay, so what is the slope of this one? So this is the slope of this one is positive. So until 3 seconds. What is the slope of this one? It is negative. It's negative 60. So negative 60. All right. Now we're going to show now the displacement again. I said that displacement is zero. So I'm going to prove that. Let's prove that. So area under the VT graph is the displacement. So let's find the area over here. What is the area over here? Area is displacement, which is BH. B is 3 and H is 40. So this is 120. So this is 120. All right, now we're going to find the area over here. All right, so the area over here is equal to displacement, which is equal to BH, which is equal to B is 2, 5 minus 3 is 2, and H is negative 60. So it's negative 120. So I have negative 120. All right, so total displacement is positive 120, negative 120. So total displacement is 0. All right, now we learned so much from this simple problem. The last thing we're going to learn is the acceleration graph. Acceleration versus time graph. So what is the slope of this one? So this is rate, the slope of this one. So acceleration. So this is constant velocity. Okay, constant velocity means 0 acceleration. So this is 3 and this is 5. So from Oxford to Cambridge, acceleration is 0. Oxford to Cambridge, acceleration is 0. Because the velocity is constant. Let's see Cambridge to Oxford. Cambridge to Oxford is constant velocity. Negative velocity doesn't mean anything. It's constant velocity. Constant velocity from Cambridge to Oxford is also 0 acceleration. Okay, so what did you learn? You learned a tons of physics from this simple problem.